students, good morning. This is yours Shalam Sai Krishna. Welcome to our online classes. Remaining concepts of the Mosley periodic table, modern periodic table about only we have to discuss in this class. According to the Mosley, we classified that elements and we arranged that elements in the modern periodic table. We classifying into the different categories. That's mean into 18 groups and 7 periods. According to the differentiating electron, that's mean last electron, we classified the elements into S, P, D, F blocks. How many blocks? 4 blocks. And we discussed in the last class, according to electronic configuration, yes, these elements are dividing into the 4 categories. One only noble gases, again one only representative elements, again one only transition elements, again one only inner transition elements. 4 types only we classified according to the electronic configuration. Yes, noble gases, representative element, transition elements and inner transition elements. That we have to try to keep in the mind. Yes, in this class we have to discuss clear information about the modern periodic table. Yes, which kind of the elements are present in which group, like that, and groups names and oxidation states and valencies and remaining concepts also we have to discuss in this class. Total how many groups are there? 18 groups are there. Yes, how many periods are there? 7 periods are there. Yes, we classified in this way. Yes, it is in a modern periodic table structure. Okay, how many groups are there? Total 18 groups are there. Yes, it is in a modern periodic table. How many blocks are there? 4 blocks are there. Yes, it is in a S block, it is P block, it is D block, it is F block. Yes, here, yes, orbital maximum electrons are how many? In S orbital we can fill the maximum electrons are how many? In S orbital we can fill maximum electrons are 2. That's why here try to keep in the mind. S block contain 2 groups, one only first A group, again one only second A group. One only first A group and again one only second A group. Yes, here just we have to try to remember first A group of the elements. Here hydrogen first element, but it does not belongs to any group. Till today there is no proper group to the hydrogen atom. Most important question. Hydrogen is present in the first atom, presence has a first element, but it is not belongs to any group. Maximum people, 99% of the people, they can consider hydrogen has a first group of element, but hydrogen don't have any group. Simply we are keeping here, but it does not belongs to any group. Okay, first group of the elements are there: lithium, sodium, potassium, rubidium, cesium, francium. What I am telling, first A group of elements: lithium, sodium, potassium, rubidium, cesium and francium. Please try to open your textbook cover page. Behind of your cover page there is a modern periodic table is there. Just you try to open that behind of your cover page of your textbook. Yes. Next second group of elements: beryllium, magnesium, calcium, strontium, barium and radium. Yes, beryllium, magnesium, calcium, strontium, barium and radium. Next here just we have to leave the D block elements. We have to discuss later about these things. What we require for our 10th class, that about only we have to discuss here. Is P block consisting how many groups? 6 groups in the last class we already discussed. Because of P consisting 3 inner orbitals, each inner orbital contain 2 electrons. Yes, we can fill with 2 electrons. Yes, we fill with 2 electrons. Is there any doubt? No doubt. So how many elements are here? 6 electrons are here. That's why 6 groups are there in the P block. Is one only third A, again one only fourth A, yes, again one only fifth A, again one only 6th A, again one only 7th A, again one only 8th A, and 0 groups. And 0 group. Yes, 3rd A to 8th A. Otherwise, 8th group we have to call as a 0 group. Okay, 3rd group of elements: boron, aluminium, gallium, indium, and thallium. Boron, aluminium, gallium, indium, thallium. Once more: boron, aluminium, gallium, indium, and thallium. Next group is 4th group, 4th A: carbon, silicon, germanium, stannum, and plumbum. Carbon, silicon, germanium, stannum, and plumbum. Next 5th A: nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, and bismuth. Next one: oxygen, sulfur, selenium, tellurium, polonium. Oxygen, sulfur, selenium, tellurium, polonium. Next is fluorine, chlorine, bromine, iodine, and astatine. Next here hydrogen, then after helium, neon, argon, krypton, xenon, and radon. Yes, how many groups about we discussed? 6 and 2. 8 groups we know. Yes, in middle there is a presence of how many groups? 10 groups are there like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First A, second A, third B, fourth B, fifth B, sixth B, seventh B, and eighth B, first B, and second B. Yes, we already started from third B and end with the second B. Third B started and second B. Yes. Here remaining D block elements also we have to discuss. Yes, here calcium atomic number is what? 20. 20 after 21. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Yes, D block elements from the scandium to zinc. These are the D block elements. Just we have to try to remember first to 30 elements. Everyone know, we already discussed in the last year only. 1 to 30 elements we know. That's why I told scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Yes, these are the D block elements. Again, some of the elements also there. That is an important for our future. Scandium, yttrium, lanthanum, actinium, titanium, zirconium, hafnium, vanadium, nobelium, tantalum, chromium, molybdenum, wolfram, manganese, technetium, rhenium, iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum. As compared to copper, some is most cost is silver, then silver more priority to gold, as copper, silver, gold, then gold to compare, platinum is high cost, copper low cost, then copper, silver is somewhat more cost, then silver, gold, then gold, platinum. That's why you have tried to remember in this way: copper, silver, aram, and platinum. Zinc, cadmium, and mercury. Zinc, cadmium, and mercury. Sir, what about this F black? Yes. Here just we know it is a lanthanum. Yes, the element with lanthanum is starting. These elements are lanthanides. Yes, lanthanides. This is an element actinium. By this element, this period is starting. That's why we have to call these actinoids. Actinoids. These are lanthanides and actinoids. Starting with the lanthanum, so we have to call the lanthanides. Starting with the actinium, we have to call the actinides. Remaining elements also present, but here in the 10th class it is an unnecessary for us. So no need to discuss about this. But here some more important concepts are here. Names. First A group name is alkali metals. First A group name is what? Alkali metals. Second A group is alkali earth metals. Third group boron, starting with boron, so boron family. Fourth group with carbon family, starting with nitrogen family. Yes, starting with oxygen here. This we have to call as a chalcogens. What is that? Chalcogens. Most important question. Starting with oxygen, the sixth group elements also called as a chalcogens. Seventh group halogens. What are those? Halogens. Eighth group zero group, noble gases, rare gases, inert gases. Is all gaseous elements, all stable elements present group. Like that, so many names are there for these 8 group elements. Once more I can repeat: alkali metals, alkali earth metals, boron family, carbon family, nitrogen family, chalcogens, halogens, and zero group elements, otherwise 8 group elements, otherwise noble gases, otherwise rare gases, otherwise inert gases, otherwise stable element group, otherwise all gases groups. Yes, these are the names for this 8th group. Here one more concept we have to remember. First group of elements oxidation state is +1. Second group elements oxidation state is +2. Third group elements oxidation state is +3. Fourth group elements oxidation state is +or-4. +1, +2, +3, +or-4, -3, -2, -1 and 0. Yes. Fifth group -3, sixth group -2, seventh group -1, eighth group 0. It is the oxidation state of the elements. Oxidation state, then valency is 1. Oxidation state is +1, valency is 1. Number of bonds also 1. Here second group oxidation state is +2, valency is 2. The number of bonds also 2. Third A group oxidation state is +3, the valency is 3. Number of bonds also 3. Yes. Fourth group oxidation state is +or-4, valency is 4 and formation of the bonds also 4. And fifth group oxidation state is -3, valency is 3. Yes, bonds also 3. Sixth group, yes, oxidation state is -2, valency is 2, formation of the bonds also 2. Seventh group oxidation state is -1, valency is 1 and formation of the bonds also 1. And then eighth group oxidation state is 0, valency is 0 and formation of the bonds also 0. That also we have to try to keep in the mind. Yes, these are the D block elements. Some of the elements about only we have to important in the 10th class, that about only we have to discuss. This is a clear information about the modern periodic table. Clear information about the modern periodic table up to the total 118 elements are there. How many elements are there? 118 elements are there. Some of the elements are, they have the radioactive nature. Radioactive nature means is it have the radioactivity nature. Is some of the elements are, these radioactive elements are man-made elements. Why we are called these man-made elements? Mean human being only, the scientists only, they developed, they discovered that new elements. That's why we have to call that elements as a man-made elements. Which elements? Man-made elements also we have to call. Yes, in the F block and yes, lanthanides and actinides of the F block also maximum elements are man-made elements only. This consisting the which nature? Radioactive nature only. Yes, these all elements, they have the which nature? They are present in the gaseous state only. Which state? Gaseous state only, but they have the stable electronic configuration. These all elements are in the stable form only. All elements are in which form? The all elements are in the stable form only. Yes, in the next class we have to discuss about the periodic properties of the elements. Yes, before that periodic properties discussed in the next class, just we have to try to remember that what is that periods about also. It is in a first period, it is in a second period, it is in a third period, it is in a fourth period, it is in a fifth period, it is in a sixth period, it is in a seventh period. Sir, what about these two periods? Actually, this is belongs to one period, this is belongs to one period. Yes, one only belongs to the sixth period, again one only belongs to seventh period. They are removed from this spot and they were keep it down. Suppose if they keep is middle of this place, at the time what will be happen? These elements will be changed in position and properties and everything will be changed. Due to the reason only they were taken and keep it down only. Yes. Just you have to observe the periodic table of our cover page behind. Yes, here to here the electron, yes, atomic numbers will be changed. Yes, in the sixth period and seventh period, try to see from here to here like that. Here atomic number will be changed. Yes, here gap will be present. That element should be presented down. That element should be presented down only. That point also we have to try to remember. 7 periods are there. First period starting with hydrogen and ending with helium. Second period starting with lithium and ending with neon. Third period with sodium and starting with sodium, ending with argon. Fourth period starting with potassium and ending with here krypton. Yes. Fifth period rubidium, yes, and xenon, yes, cesium and xenon and francium and radon. Yes. Once more, hydrogen, helium, lithium, yes, neon. Next to sodium, yes, argon. Next to potassium, again krypton, again rubidium, again xenon, again cesium, here radon, last francium. For this one of the new element oganesson. What is that? Oganesson. Starting 7th period starting with francium, ending with oganesson. Hydrogen, helium, like that. Lithium, neon, sodium and argon. Like that only, one only starting element, again one only ending element only. Simply we have to try to that atomic numbers for these elements. Yes, atomic numbers we have to write. Yes, simply we have to try to keep the formula 2, 8, 8, 18, 18, 32. 2, 8, 8, 18, 18, 32. Yes, 2, 8, 8, 18, 32. Simply, one atomic number of the hydrogen is 1. 1 plus 2, it is in a 3. Yes, here 2 added 1 plus 2, it's become as a 3. For this 3 2 you have to add 8, it's becoming as a 11. Yes, 11. 3 plus 8, it should become as a 11. Next 11 2 you have to add that one more 8, it should become as a 19. Yes, this 19 should add to 18, 37. This 37 should add to 18, 55. 55 you should add to 32 at that time it should become as a 87. Atomic numbers we have to try to write in this way. 1 plus 2, 3, 3 plus 8, 11, 11 plus 8, 19, 19 plus 18, 37, 37 plus 18, 55, 55 plus 32, next 87. Is like this. You have to try to write the atomic numbers of these group elements. 2, 8, 8, 18, 18, 32. This sequence you have to remember. 1 we already know, then 2. Next 3, 4, 3, 4, 5, 6, 7, 8, 9, 10, 11 already here, 12, 13, 14, 15, 16, 17, 18, 19, okay, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. See how it is simple way. 1 already here, 1 after, 2. Next 3, 4, 5, 6, 7, 8, 9, 10. Then 11 already here. 11 after 12. 13, 14, 15, 16, 17, 18. Already 19 is here. Then 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. As usual, you have to continue these things. Is there any doubt? No doubt. Remaining concepts we have to discuss in the next class. Thank you so much.